Hey guys, so this is the first video that you should be watching to learn a little bit about how we can go about doing some engineering calculations for dynamic entertainment pieces. Whether you're doing a parade float or a dynamic set piece for a stage production, this is the place to start. So, we're going to be talking about tipping calculations for our dynamic entertainment pieces and how we're going to be approaching those. So, essentially, we are going to employ the first law of thermodynamics to analyze our system. The first law of thermodynamics in our application really doesn't have anything to do with heat or anything thermo-related, but instead it's telling us that the energy in a system is a constant value. That is, the energy in a system cannot be decreased or increased without external work put into the system. This is going to make a little bit more sense when we talk about the different methods for energy storage in a system. So how do we analyze the energy of our systems? And in general, there's two things that we're going to be interested for in our dynamic entertainment systems. And those are going to be kinetic energy, or the energy of movement, and then gravitational potential energy. And that's the energy due to the gravitational pull of the Earth. So to think of it like this, when we hold our pencil up above our desk, there's gravitational potential energy stored in the pencil because it is held up high. When we release the pencil, it begins to move and it gains kinetic energy. However, if we look at that system, the velocity at any one point in time will be proportional to the height at which you dropped it from. That's going to make a little bit more sense when we look at the kinetic energy and gravitational potential energy formulas in the next couple of slides here. So, kinetic energy is given by the relationship that it is equal to 1/2 mv squared, where mass is given by m, and the velocity of the system is given by b. Now, velocity is just a fancy word for speed. So, this tells us that kinetic energy is a direct function of the mass and velocity in the system. But in our case, if we were to talk about something a little bit more complex, we'd get into the question of which velocities are important. If you're interested in learning more about that, feel free to reach out to me. In the case of your system, you're going to just use the velocity that you determine. Now let's talk about gravitational potential energy. Gravitational potential energy is given by a relationship mgh, where once again mass is m, g is the gravitational constant. More often than not, we'll see that in 9.81 meters per second squared. You can also get that in US customary inches and other different unit systems if you just do a quick Google search. Now, h is the relative height of the system. Now, this brings into question, what does relative mean? Relative means that we are going to be taking the h value from some standard point, from some datum. We're going to be talking about what that point is for each system we analyze in the two following videos. So that's our brief introduction to the entire idea of the energy methods that we're going to be using to analyze our system. For a more detailed discussion of how this applies to our parade floats as well as our dynamic set pieces, go ahead and find that corresponding video also listed below.